The Appalachian Trail is 2,174 miles long, and the circle graph below, well, that's not a circle graph. It was supposed to be, but that didn't work out. Anyway, but we do have a list of all the percents, and it shows the percent of the trail that is in each state. By the way, a couple random thoughts. If I was to add all this together, what should it equal? Well, this is percent, so it's the part out of 100, and if I've listed everything, then it should add to be 100%. One other random thought, it actually goes through West Virginia as well for just a little tiny fraction, and so one of these actually was rounded up a little bit too much, or more than one of them was rounded up too much, and we have West Virginia in there as well. But I left that out because it was such a small fraction. Okay, or small percent. So how many miles of the trail are in Maine? Well, I don't know. I do know that 13% of the trail is in Maine, and I don't know how many miles that is. So what I'm going to do is make a sentence out of what's going on in my head right now. So I'm going to write this down. So what is 13% of the total number? So 13% of that many miles is how much is in Maine, so it's 2174. So that's my question, and I'm going to turn that question into an equation, and then we'll solve that equation. So when I see the word what, that means, well, I don't know what it is, and I'm going to use a variable. So what is x or n or whatever letter you want it to be, is equals, and 13%, well, 13%, and we've been through this, but 13% means I can take this decimal and I can slide it over two places. So when I have 13%, the decimal's here, and I'm going to go two places, and I have 0.13. And of, in case you never knew, of means multiply. So it's times, that's not x, that's times, not to be confused with x. I'll probably start using n, just so it doesn't look like the x, of 2174. So here's the deal. The number of miles of the Appalachian Trail that are in Maine is, notice what I'm pointing at, 13% of 2,174. So at this point, it's just basic straight up multiplication. So let's just basic straight up multiply. There we go. Let me get the light here better. There it is. It's kind of bright, but it'll work. So 0.13 times 2174, and we have that 282.62 miles of the Appalachian Trail are in Maine. So I'm going to write that down, 282.62 miles. And now we do the same thing for these states, and it's pretty straightforward. I'm going to do one more state, and whatever I don't finish is your job to finish, okay? So how many miles of the trail are in North Carolina, not what percent, because they tell me that in North Carolina there is 4% of the Appalachian Trail, and so what I'm going to do is find out what is 4% of 2174. That's the total number of miles. I'm going to zoom in just a little bit here. There we go. You don't have to write the sentence every time, but the process is the same. I'm going to use a different letter. I'm going to use n. Is means equals, and 4% is 0.04. So let me demonstrate that very quickly. If I had 4%, I have 4 decimal, 4 point, and so then we go boom, boom, we move it back 2 places, and it's 0.04. And of means times, there's an exception to that, and 2174, and then we'll multiply. So 0.04 times 2174, and when I hit enter, well, you can't see it, but when I hit enter, you'll be able to know how many miles of the Appalachian Trail are in North Carolina, and it's 86.96. So 86.96 miles. Okay, the rest are up to you. So here we go. Let's do a handful of the word problems, not all of them, and again, whatever I don't finish, it's your job. There is a worldwide shortage of nurses. In 2003, however, 2,178 of the 2,593 nursing schools in the United States had an increase in applications or enrollment. And what percent of the nursing schools had an increase? So there seems to be a positive trend in nursing, at least from what we see from 2003. However, that was quite a while ago, so we don't really know if that's working or not. So here's the deal. I'm going to do this one particular way, and then I might backtrack just a little bit and do it this way, where I write a sentence, because you can think of it more than one way. So 2,178 out of that many. And so basically we have a fraction. We have this many schools that showed an increase in their nursing program out of this many schools that offer a nursing program. And we want to know what the percent is. Well, we're just basically converting a fraction to a percent. And we've done this before. You can think of it as a proportion. You could do this if you wanted to. But it is the same thing as doing what I'm about to do on the calculator. You can simply just divide it. You'll go 2178 divided by 2593, and you get that. And I'm going to write that down. I'm going to round that, though, the 995, that's going to round that up to 0.84. So we really have 0.84. But let's be realistic. 0.84 isn't a percent, so it's really 84%. Now, that's probably the easiest way of thinking about it, but that's not the only way of thinking about it. So I'm going to keep going a little bit, and I'm going to take this problem apart a little bit differently. 2,178 of the 2,593 nursing schools in the United States had an increase. What percent had an increase? All right, I'm going to put in words what's going on in my head. Now, if you're thinking, oh, I've already got the answer, let's not even pay attention. Really, we need to understand the structure of the equations because they're not always going to be this straightforward. So, 2,178 out of 2,593 is what percent? The process is the same, but now we've put it kind of like a sentence, which will become an equation. Out of means divide. And is still means equals. And the word what means, well, I don't know. So 2,178 divided by 2,593 is what percent? Well, I don't know. So I would do exactly what I just did, and I would get 0.84, and that's great. But I haven't answered the question until I've told you what percent it is. And so I'm going to move the decimal over 2 places to 84%. That's 2 different ways of doing the same problem. Okay, I'm going to keep going, and we'll do a few other problems. Last Friday, there were 17 freshmen absent from school. I made that up, by the way. And this represented 4% of the total number of freshmen. How many freshmen are there? Whoa, what? Confused. So I'm going to do it the way that I think about it. Here's what happens in my head. It doesn't have to be what happens in your head, but this is what happens in my head. I'm going to take what I've read and process it and make a sentence out of it. And I'm going to include in my sentence the question. All right, let me say that again. I don't know how many freshmen there are. So 4% of what? What? I don't know what. That's how many freshmen there are. Is 17. Your mind may have gone there. It may not have. I'm going to show you another way as well once I finish this one. So 4% of what? 4% of the total number of freshmen is 17. Because when there were 17 that were out, I said, man, 4% of the total is out. So let's go ahead and change 4% to a decimal. The decimal is here right now, and we're going to move it over 2 places. So 0.04 times is what of means what? I don't know. I'm going to call it F for freshman. Is means equals, and 17 is just 17. And we solve this equation. So I'm going to stop this thought right here, and I'm going to go into something slightly different. And I'm going to just abandon this problem for just a second. Bear with me. You don't have to write it down. Just watch. If I handed you a problem and I said 4x equals 12, what would you tell me x was? Well, hopefully you would say 3. And here's what happened. On your paper or in your head, you would divide by 4. You're dividing. You're undoing what's been done. This is 4 times. The opposite of times is divide. So you divide and you get 3. All right? So, same idea here. 0.04 times something gave me 17, so I'm going to divide by 0.04. 0.04. We do that, and F is equal to 17 over 0.04. And we just type it in the calculator. And this is what goes through my head. Doesn't have to be the way you do it. 425. There are 425 freshmen. I'm going to put that word in there just so we can put it in context. There are that many freshmen. Okay, let me do it a different way. And this might have been the way that you've seen it before. So I'm going to draw a little thing here just to kind of separate the problems. 17 is not the whole total number of freshmen, right? This is the piece. This is a part of the freshmen that were out. So we have 17 that were out. So there are 17 that were out divided by the total number. What I'm going to do is part over the whole. Some people think about it this way. So part over whole. I'm going to write that over here. Part over the whole equals percent over 100. That might be the most straightforward way that some of y'all would want to do this. Part over a whole equals percent over 100. 17 out of, well, I don't know how many. Well, I know the answer, but let's pretend like I don't. Is equal to 4%, so it'd be 4 out of 100. And then we do the same thing we've been doing where we cross multiply. It's a proportion, we just set it up and we cross multiply. So we cross multiply, we have 17 times 100, that is 1700, about wrote the wrong thing, equals 4F. We divide by 4, we've been through this, and we end up with the exact same thing, F is equal to 425. So you can do it as an equation, or you can set it up as a proportion. Either way, it's fine. I'm going to do the next one both ways, and then I'm going to start skipping around and doing a few random problems. An inspector found 25 defective bolts during an inspection. If this is 1.5% of the total number of bolts inspected, how many bolts were inspected? I'm going to start with this method where I'm going to do, let me write it again just for fun, part over the whole equals percent over 100. Let's do it that way. Okay, there were 24. That's not all of them, that's part of them. We found 24 that were defective, but I don't know the total number that was inspected. So 24 out of, I don't know what it is equal to 1.5 out of 100. Okay, I'm not finishing that one. That one's your job. But I am going to do it this way as well. All right? So if this is confusing you, mute it for a second and just keep on working. I'm taking this problem and I'm putting it in context, just in my head, thinking, okay, how can I solve this? What do I need to do? What is it asking? Well, it's really saying 1.5% of what is 24? It's really asking me that. So we can write an equation with that, and we'll move the decimal 2 places. So 0.015 times some number n or whatever, x, is 24. And we do the exact same thing. Honestly, in the end, this work is pretty much the same thing. It's just a different way of looking at it. Okay. I am going to flip it over to the back. And let's see. Just going to do one more problem on the back, and then we'll hit some of these right here in this section, just a couple of those. In a recent year, approximately 32% of the films were rated R. If 725 films were rated, how many were rated R? I'm going to do it the part over the whole way first, so you don't have to write this every time, but it helps me explain it. Part over the whole, and that's percent over 100, and so we'll do 32% of the films were rated R. Okay, well, that's the percent. That's 32 out of 100 films were rated R. You have 100 films, more than likely 32 of them were rated R. And 725 films were rated. Okay, now let's stop. Is 725 the part or the whole? Was this how many were rated R, or is this how many were rated in general? Well, it's asking how many were rated R, and I don't know. But I do know there were 725 total, and I don't know how many were rated R. Okay? All right, let's slide down. By the way, you finished that. That's your job. Slide down a little bit, and let's do a couple of these. I'm going to do 1 or 2 up here, and then we'll do just a couple over here, and then I will let you finish whatever's not done. So number 1, 13 is some percent of 16. I'm going to call it n times 16. Of means times most of the time. There's an exception. but we'll divide by 16. And when we do, we're just left with this. We grab a calculator. 13 divided by 16 gives me 0.8125. I'm going to write all those decimals. And that is 0.8125. That is equal to n. And that's fantastic, but I'm not done. And here's the reason I'm not done. I'm not finished because I'm looking for the percent. And since I'm looking for the percent, I need to convert this to a percent by moving this decimal over 2 places to the right. So 1, 2. So 81.25%. Let me refresh your memory just a little bit. You might drink Dr. Pepper. If you have a decimal and want a percent, you move to the right. You still might have a decimal in there, but that's okay. It doesn't have a percent sign after. If you're here, it doesn't have a percent sign. If you're here, it has a percent sign, and you would move the decimal to the left 2 places. Always 2 places because we're dealing with things out of 100. Okay, I'm going to do number 4, and it says 1 out of 45. This is the exception. This is when of doesn't mean times, but out of, we did this on the front, out of means divide. So 1 out of 45 is equal to what percent? I don't know, I'll call it X. And so we just simply divide that. So we do 1 divided by 45. And we get that disgusting mess. I'm going to round it off a little bit. I'm going to call it 0.0222, and let's just leave it there. You can put the bar over it if you want to. But we're not finished because it's asking for a percent. So we're going to move the decimal over 2 places. So 2.22%. That is the answer. Okay, I'm going to do number 12 because it's one of the wordy problems in here. So let's do this. First year profits of a business were 900. Second year profits were 1,200. What percent of the first year profits were the second year profits? What? Okay, I'm going to do this one a little bit differently. I'm going to do it using the part over the whole thing. So the part is, my voice is cracking, the part is 900, the whole is 1,200. And it's asking that because it's what percent of the first were the second. So this one's wordy. If I wanted to look at the first year profits as part of a whole, it would look like this, and it would be some percent out of 100. I'm not going to finish that. I'll let you do that. Okay, I'm going to do number 14. I'm not going to finish. I'm going to start it. A team won 16 games, lost 6, and tied 2. Stop right there. They never told you how many games they played, but you can figure it out very easily. If you win 16, you lose 6, and you tie 2, you add all those together, and you'll find out how many games you played. And it is 24. 24 games total. That is how many games you played. So we're going to go with that. So here goes 14 again. This is how many games they played. It tells us what happened in each game. What percent of the games did they win? Okay, part over the whole. They want to know the wins. So I don't need 6. Those are losses. I don't need 2. Those are ties. I do need 16 out of 24. And it says what percent did they win. So it's what percent out of 100. And you can finish that.